Hey, welcome to the problem solving session for chapter 11, the last chapter of the Organic 1 chemistry sequence, where we are focusing on the reactions that alcohols undergo. So in this segment, we're going to be going through the 4 questions from the problem solving worksheet, which you can find and work on your own if you go to the course Canvas page and you look under files for the problem solving section. You will see a worksheet for this. I strongly recommend you work through the worksheet on your own as best you can and use these videos as a chance to check your work. Or if you get stuck on a particular problem, use this video as a way to work through that barrier. So there will be a video for each of the 4 questions, 4 separate videos, and this is the video that goes with the first question, where we are asked to classify each reaction as an oxidation, a reduction, or neither. So let's take a look at this. First thing you need to keep in mind here, I've written your key points up here in your upper right-hand corner. This is what you need to burn in your brain when you're thinking about oxidation and reduction for purposes of organic chemistry. When we think of oxidation in the world of organic chemistry, we are referring to the oxidation of the organic molecule. That's what we are focusing on as our frame of reference here when we think about oxidation. And how we are going to determine that an organic molecule has been oxidized is if we compare the structure of the product to the structure of the reactant, we will see that in the product, there's been an increase in the number of bonds that connect carbon atoms and electronegative atoms, atoms such as oxygen or atoms such as halogens. Another way to look at this is that there has been a loss of H2 in order to bring in the electronegative atoms in their place, and or you will notice in the structure of the product that you have brought in an extra oxygen, O2, or X2, where X is one of your halogens. So if you've added Cl2 across a carbon-carbon double bond, you would classify that as an oxidation reaction because you've brought in atoms that are more electronegative than carbon. Reduction is the opposite. So in reduction, you will notice that the product has fewer covalent bonds between carbon and the electronegative atom than the reactant had. And it's going to correspond to a gain of hydrogen, H2, and or a loss of oxygen or the electronegative atom, such as the halogen. So let's use this information to tackle this problem. So in part A, we look at the relationship between the product of each reaction and the reactant. So here we're going from an alcohol, ethanol, to acetaldehyde, a 2-carbon aldehyde. And you will notice that in going from reactant to product, the number of carbon-oxygen bonds has increased from 1 direct bond between carbon and oxygen to 2 direct linkages there. Additionally, in order to accomplish that, you would be removing one of the hydrogens here because originally you had CH2, and over here you just have CH. And so based on all of this information, the fact that we're decreasing the number of bonds between carbon and hydrogen, increasing the number of bonds between carbon and oxygen, we can classify this reaction as an oxidation by relating the structure of the product to the structure of the reactant. That's how we classify this as an oxidation type reaction. Then we come to the next reaction here. And what we notice here as well is that we're going from a structure that has fewer covalent bonds between carbon and oxygen. Here there's a total of 2 covalent bonds between carbon and oxygen. To over here, there's a grand total of 3 covalent bonds. We have our double bond to oxygen, single bond to oxygen, making a grand total of 3. We are also in this process decreasing the number of bonds between carbon and hydrogen because our carbon-hydrogen bond here that we had in the reactant, when we come over here to that same carbon, that carbon in our product has no carbon-hydrogen bonds whatsoever. And so therefore, this reaction is also classified as an oxidation reaction because we're increasing the number of bonds between carbon and that electronegative oxygen atom. And as a consequence of that, we're also decreasing the number of carbon-hydrogen bonds, which is a very common theme we'll see. So onward to the next question. So in this reaction, we are looking at taking osmium tetroxide and reacting osmium tetroxide with our alkene. And in reacting osmium tetroxide with our alkene, we are creating new carbon-oxygen bonds here. So in going from reactant, we had carbon-carbon double bond to product, we have carbon-oxygen bond here and here. So we are effectively adding O2 across the carbon-carbon double bond. And as we see over here on our list of oxidation, O2 is one of the examples of a scenario that classifies as oxidation. Clearly, we've increased the number of bonds between carbon and oxygen going from our reactant to our product, so that is how we can classify this as an oxidation reaction, an oxidation process going on here. Then we come down to the third reaction here, which is an epoxidation reaction, where we are starting with an alkene and we are reacting with a peroxy acid, and the product of that type of reaction is an epoxide. And by looking at the relationship between the starting material and the product here, we can classify this reaction also as an oxidation because we've increased the number of covalent bonds between carbon and oxygen and going from our starting material to our product here. Then onward to the next part of this. In the next part, we see that we start the reaction with 2 bonds between carbon and oxygen here and here. And the product still has 2 bonds between carbon and oxygen here and here. All that has happened in this reaction is that we've broken open this epoxide ring. Epoxide rings, that 3-membered ring with an oxygen, are very, very prone to opening up because there's a lot of angle strain in that molecule due to the bond angles being constricted here to 60 degrees when they would really rather be 109.5 since they're sp3 carbons. So that ring opens very easily, but this particular reaction is neither an oxidation nor a reduction because we're not increasing or decreasing the number of bonds between carbon and that electronegative atom. So this one we're going to plug in as neither oxidation nor reduction. So keep these guidelines in mind up in the upper right-hand corner of your screen as you're thinking about and evaluating any scenario relating the product to the reactant and asking yourself, is this an oxidation process? Is this a reduction process? Or is it none of the above because neither of those oxidation or reduction criteria apply?